Understanding the energy budget of ecosystems is more than just albedo and temperature. Because so much energy goes into evaporating water, the two are tightly linked. Here, we'll start with an overview of ecosystem water budgets. The authors state that the water available to support the productivity of ecosystems depends on the balance between inputs and outputs. An ecosystem behaves like a bucket that is filled by precipitation and emptied by evapotranspiration and runoff. And this model is essentially called the bucket model of ecosystems. And if you were to imagine a bucket with water going in and then water going out, this is essentially how the simplest model of water budgets for ecosystems are thought of. And a bucket is actually a pretty good metaphor. So with lakes, for example, the pool and flux model works pretty well. Modeling the water budget of a lake, you start with the inflow and think about how much water is coming into the lake from streams, for example, and the outflow, how much water is leaving a lake from streams or river that drain that lake. In addition, there's exchanges with the atmosphere. Precipitation brings water into a lake, and evaporation brings water out, takes water out of a lake. And so this is a very simple bucket, but it's a very powerful one to understand the water budgets of ecosystems. So again, we're going to think about inflows and outflows from the surrounding terrestrial ecosystems, as well as exchanges with the atmospheres, inflows being precipitation, evaporation being outflow. And then the size of this lake, or the amount of water, is really then the balance of inflows and outflows, with an understanding that buckets can only be so big and only hold so much water. So here's a picture of a dam, and this really is one way that when we go to ecosystems, we start to do some of these calculations of what inflows and outflows are. So it's really simple in some cases to measure outflows of water from a lake, because most of those outflows come through one simple point, and we can measure that. The height of the water behind this dam is going to be dependent on the rate at which water leaves it. So if the gates on the dam stay relatively closed, the water level might be up here. If we open them, it's going to be lower because inflows are going to increase. Now, the model that they use for terrestrial ecosystems is relatively similar to what we just had for lakes. Essentially, you have arrows going down into the ecosystem. Precipitation is the main one going down. And you're going to have arrows going out. So water can leave an ecosystem because it runs off the surface. So it hits the surface and runs off. It can also percolate, infiltrate and percolate, and then you have water leaving the ecosystem through base flow. And that's groundwater, where you have a flow underneath the soil surface. We also have evaporation and transpiration in a terrestrial ecosystem, and those are two of the main outflows for the system. And once you know that, how much precipitation there is, how much evaporation there is from a canopy or the soil surface, how much transpiration there is, as well as surface runoff and base flow, you can then calculate, if this were to be considered a bucket, what the level of the bucket is and how much water is stored in that bucket. Now, these calculations can also be done on a global basis, and we can start to quantify on a global basis how water gets used. This here is a figure of what's called green water and blue water uses, all within the realm of ecosystem services. Green water is water that's available for plants to transpire, and blue water is water that's available in lakes and rivers and groundwater, for example, that might be available to humans. So you can see that there's differences in the size of the arrows. So forests and woodlands, grasslands on a global basis are transpiring over 25% of the water that enters into ecosystems. And then you've got other water fluxes such as food. So irrigation is going to use somewhere on the order of 4% of all the water on a global basis. Some of this blue water, storm runoff, and then other of the smaller arrows here is what is used to fill up the reservoirs that we have in the lakes, as well as the groundwater reservoirs too. So there's really big differences, and you can see that humans, by altering how much cropland we have, and then how much forest versus grasslands there are, and as well how much gets used for other purposes, really can affect the water budget on a global basis.